Welcome to the Deep Dive. Today we're looking into something that powers almost everything we do, technology.
That's right. We're online constantly, aren't we?
Mhm.
Streaming, browsing, listening to conversations like this one.
Exactly. But have you ever really stopped to consider the environmental side of all that, the footprint it leaves?
It's so easy to overlook.
Hmm.
But every click, every download, every bit of data needs electricity.
And a lot of the electricity, globally speaking, still comes from fossil fuels. So there's a real carbon cost hidden behind our screens.
A very real cost. And the scale we're talking about is just huge. Think about the data centers, the actual physical infrastructure behind the internet.
Yeah, our sources dug into that. The International Energy Agency, they had a figure for 2022. Data centers worldwide, around 460 terawatt hours of electricity used.
460 terawatt hours. To put that in perspective for you, that's more than Sweden. The entire country of Sweden uses in a year.
Wow, more than Sweden.
And it gets more urgent. If things just carry on as they are, that number, it's projected to jump to maybe 620 terawatt hours by 2025.
Okay, so that's a massive increase looming. It really throws the challenge into sharp relief, doesn't it? How do we square our growing dependence on tech with, needing to slash our environmental impact?
That is precisely the question. And it leads us straight into green IT.
Green IT. Right.
Yeah, it's basically this whole collection of practices, technologies, strategies, all aimed at reducing the environmental footprint of, well, information technology.
So it covers a lot of ground then, like the energy efficiency of our gadgets, the big servers, but also software maybe, and what happens to tech when we're done with it.
Exactly. The whole life cycle. We're talking energy efficient hardware,
Mhm.
making the cloud greener, using AI to optimize things, circular economy ideas,
Yeah.
getting smarter about e-waste. It's broad.
Okay, so our mission for this deep dive is to unpack all that, explore this paradox, really. Technology uses tons of energy, but it also seems to be becoming a really powerful tool, maybe even essential for fighting climate change.
It's a fascinating dynamic. Let's start with those energy giants we mentioned,
Yeah.
data centers.
Right, the backbone.
They are the physical heart of the internet and the cloud. Rows and rows of servers storing, processing, just immense amounts of data.
And all that processing generates incredible heat, which then needs, well, massive cooling systems, which also use a ton of energy. It's like a cycle.
It is a constant energy battle, but this is also where we're seeing some really cool innovation. The big tech companies are putting serious effort in.
Like Google.
Like Google, yeah. Carbon neutral since 2007, apparently.
Yeah.
And they have this really ambitious goal, run entirely on carbon-free energy, 247 by 2030.
247 carbon-free by 2030? That's...
Ambitious is the word.
And they're using tech itself to help, right? I saw something about AI.
That's right. Using DeepMind AI to manage their data center cooling systems much more intelligently. They've cut the energy needed for cooling by up to 40% in some cases.
40%. Just from smarter software managing the physical stuff.
It really shows the impact AI can have. And Microsoft, they're also investing heavily, building data centers powered by renewables. They even did this really interesting experiment.
Oh, yeah. What was that?
They put a data center underwater off the coast of Scotland.
Underwater? Seriously? Why?
Well, to use the cold ocean water for cooling, passive cooling, basically.
Ah, clever. Did it work?
It did. It was more energy efficient, as you'd expect. But interestingly, they also found the servers failed less often down there. The cold, stable environment seemed better for the hardware.
Huh. Fewer failures, too. That's pretty neat. Using the environment itself. Okay, so optimizing the big data centers is crucial. What about the shift to the cloud? Is moving stuff to the cloud automatically greener?
For most companies, yes, definitely. Think about it, instead of running your own, maybe inefficient servers in a back room somewhere.
Which might be half empty most of the time.
Exactly. Underutilized. You move that workload to these huge, hyper-optimized data centers run by giants like AWS or Google Cloud or Azure.
So it's about efficiency of scale. Fewer, bigger, better run facilities instead of thousands of small ones.
Precisely. These providers can invest in the absolute latest cooling tech, the most energy-efficient hardware, renewable energy contracts, stuff that's just not feasible for smaller individual businesses.
And the numbers back that up, right? There was an Accenture study mentioned.
Yeah, quite striking. They found migrating to the cloud could cut energy consumption by up to 65%.
65%. Okay.
And, maybe even more importantly, cut carbon emissions by potentially 84%.
84% reduction in carbon. Wow. That really highlights the potential, doesn't it? Just by changing where the computing
It's
happens.
a massive lever.
Yeah.
And tied into that is virtualization.
Ah, yeah. Explain that quickly.
It's basically running multiple virtual computers, like separate operating systems and applications on a single physical server.
So you need fewer actual boxes.
Exactly. Less hardware means less manufacturing impact, less energy draw, less cooling needed. It's another layer of efficiency, even within those big data centers.
Okay, so we've got the huge infrastructure side. Data centers, cloud, virtualization. But what about, the stuff we actually touch? Our phones, laptops, monitors. They have a footprint too.
Oh, absolutely. And this brings us to a really major and frankly, quite alarming issue. Electronic waste, e-waste.
Yeah, the stats on this are, well, they're not great.
Pretty grim, actually. The UN figures for 2022 showed over 62 million metric tons of e-waste generated globally in 1 year.
62 million tons.
And the really worrying part, less than a quarter of that, less than 25%, was actually documented as being properly collected and recycled.
So 3/4 or more is just ending up where? Landfills, incinerators, shipped somewhere it shouldn't be.
Likely all of the above. It's a huge mountain of discarded electronics, full of valuable materials we could recover, but also toxic stuff that can harm the environment and health.
62 million tons. I read somewhere that's like throwing away the weight of the Great Pyramid of Giza in electronics every couple of years.
That's a powerful image. And it's why Green IT really pushes the 3 R's for hardware. Reduce, reuse, recycle.
Reduce, reuse, recycle. Okay.
So reduce. Do you really need that new phone every year? Can you make your laptop last longer? Reuse. Can older equipment be refurbished, maybe donated or sold for a second life?
And recycle. Making sure it goes to the right place when it's truly dead.
Exactly. Using certified recyclers who can safely extract the valuable metals and handle the hazardous components properly, not just chucking it in the bin.
And some companies are making noise about this, right? Like Apple.
Yeah, Apple's made some efforts. They developed this robot, Daisy, that can take apart iPhones pretty quickly, like 200 an hour, to recover materials like cobalt and rare earths.
Recovering the valuable stuff.
Right. And they've also made this pledge, this long-term goal, to eventually build all their products using only recycled or renewable materials. That's the kind of circular thinking needed.
Moving towards a circular economy for tech. Okay.
Yeah.
Let's shift gears slightly. Remote work. Huge change for many of us recently.
Massively accelerated by the pandemic, yeah.
And while there were lots of reasons for it, it definitely seems to have an environmental upside.
A pretty significant one, potentially. Fewer cars commuting every day. Fewer business flights.
Yeah.
It adds up.
Is there data on that?
There is. A study by Global Workplace Analytics in 2021 estimated that if U.S. workers worked remotely, just half the time,
It's just half the time.
it could cut greenhouse gas emissions by something like 54 million tons a year.
54 million tons. That's substantial.
It really is. And again, technology enabled that shift, didn't it? The tools we're using right now, Zoom, Teams, Slack, all that collaboration software, it allowed this lower carbon way of working to happen on a massive scale.
Technology facilitating a greener behavior pattern. Interesting angle.
And tech is also being used to make the physical world itself more efficient, beyond just how we work.
You mean things like smart buildings, using AI and IoT?
Exactly. The Internet of Things networks of sensors, connected devices, combined with artificial intelligence. It lets us monitor and optimize energy use in ways we couldn't before.
So how does that work, practically speaking, in a smart building?
Well, imagine sensors everywhere, monitoring room occupancy, temperature, light levels, how much energy each system is drawing, all in real time.
Okay, gathering tons of data.
Right. Then an AI analyzes that data constantly and makes adjustments on the fly. Dims the lights in empty meeting rooms, tweaks the heating or cooling based on who's actually there and the weather outside, maybe even predicts when peak energy demand will hit and adjusts usage beforehand.
So it's like the building is constantly fine-tuning itself to avoid waste?
That's the idea. Companies like Siemens, they offer tech like this, and they claim it can cut energy use in commercial buildings by up to 30%.
30% is a big chunk.
It is. And it's not just buildings. Cities are doing this too. Singapore is often cited as an example, using AI and IoT to manage traffic flow, reduce idling, and fuel use.
Right. Smoother traffic, less pollution.
And also things like optimizing the power grid. Monitoring air quality shows how data and AI can make these big, complex systems much more dynamic and efficient.
Okay, we have to talk about blockchain, though, because that often comes up for, well, the opposite reason, doesn't it? It's energy use, especially crypto.
Ah, yes. the elephant in the room sometimes. It's a crucial point because certain types of blockchain, particularly Bitcoin with its proof-of-work system.
Proof of work, the mining thing.
Exactly. That process is incredibly energy-intensive by design. Our sources pointed out that in 2023, Bitcoin alone used more electricity than Argentina.
More than Argentina. The whole country.
The whole country.
Yeah.
Well, it's a staggering amount of energy just to validate transactions on one network.
It really is hard to get your head around that kind of consumption.
It is. But, and this is important, the story isn't static. There's been a really significant development. Ethereum, which is the second biggest cryptocurrency.
Right, Ethereum.
They successfully switched away from proof of work in 2022. They moved to a different system called proof of stake.
Proof of stake. Okay, and what did that do to its energy use?
This is the key part. It slashed Ethereum's energy consumption by over 99.95%.
Whoa, 99.95%. That's not just an improvement, that's transformative.
Completely transformative. It demonstrates that the massive energy drain isn't inherent to all blockchain tech. It's specific to that proof-of-work model, which needs raw computing power. Proof of stake works differently, using economic incentives people staking their crypto, which needs vastly less energy.
So it shows the technology can actually evolve to fix its own environmental problems.
Precisely. That's a really key insight here. It's not necessarily the concept, but the implementation that matters for energy use. And it can change rapidly.
Okay. Wow. We've covered a lot. From data centers in the cloud to our own gadgets and e-waste, remote work, smart cities, even the crypto energy debate.
It's clear, isn't it? Technology is tangled up in our environmental challenges, definitely. But it's also offering some incredibly powerful solutions.
So pulling this all together, what does it mean for, for you listening, for us? What can we actually do? But the sources had some practical takeaways.
They did, both on a personal level and for businesses. Let's start personally.
Simple habits seem key, like actually turn off your devices, your screens when you're not using them. Don't just let them sleep.
Yeah, and unplug chargers, phone chargers, laptop chargers.
Yeah.
They often draw phantom power even when the device isn't connected or is fully charged. It adds up.
Oh, and the dark mode thing. If your phone or monitor has an OLED screen.
Right. On OLED screens, black pixels are actually turned off. So using dark mode genuinely saves energy compared to bright white backgrounds.
Good tip. Also, thinking about upgrades. Do you really need the newest model every single year?
That's fundamental. Just making your current devices last longer is one of the best ways to cut down on resource use and e-waste generation. Reduce first.
And then, when it is time to replace something, recycle the old one properly. Find a certified e-waste program. Don't just bin it.
Absolutely critical. Okay, now for businesses or people making decisions in organizations.
Cloud migration seems like a big one. If you're still running lots of on-premise servers, look seriously at moving to the cloud.
Definitely. And audit your IT energy use. You need to know where the energy is going before you can reduce it effectively. Measure it.
Makes sense. Choosing suppliers, too. Like looking for hardware vendors or service providers who have good environmental track records.
Yes, use your purchasing power. And train your teams. Make sustainable IT practices part of the culture. Little things everyone does can add up.
So looking forward, the sources seem pretty hopeful overall about tech's role.
Yeah, the vision is that as the world pushes towards net zero emissions, technology won't just be cleaning up its own act, it'll be a core part of the solution for everyone else.
How so? What kind of future tech are we talking?
Well, things like maybe biodegradable circuit boards, so electronics decompose safely, AI designing new computer chips that are inherently way more energy efficient.
Designing for efficiency from the start.
Exactly. Or even data centers that go beyond carbon neutral to become carbon negative, actually capturing more CO2 than they produce, perhaps using waste heat productively.
Carbon negative data centers. That would be something.
The big idea is tech moving beyond just mitigation to actively helping reverse the damage and enabling sustainability across society.
Okay, so here's a final thought to leave you with. Every single thing you do online, sending an email, watching a quick video, even just searching for something, it all uses energy. It contributes to that global footprint we discussed.
It does. But what this deep dive into green IT hopefully shows is that while that footprint is real and, frankly, growing, the same technology that creates it is also developing these incredible ways to shrink it, optimize it, maybe even reverse it.
It kind of challenges us, doesn't it, to see tech not just as a tool for work or fun, but as something that directly impacts the planet's health.
So the question for you is, Knowing technology is both a huge energy user and a potential engine for solutions.
Yeah.
How does that shape your choices, your habits? How do we collectively make sure we're steering this powerful force towards building a genuinely sustainable future?
It's a massive potential waiting to be fully harnessed.